Hello everyone, this is Mr. Jackson, and today we're going to finish up Concept 2 over all things nutrition and metabolism, going into Part 2, where we're going to focus in on what we're talking about when we use the word metabolism. Okay, so this is going to be a very key part of our discussion when it comes to digestion and actually utilizing our body's nutrients that we take in. So let's get right into it. So whenever we say metabolism, this is referring to all of the biochemical reactions that are happening in our body. So all of the reactions, including our biochemistry. Okay, now that can be broken down into two major categories. You have your anabolic reactions and your catabolic reactions. Okay, so anabolic is just basically you're linking simple molecules together to make bigger complex ones, right? So this is more like if you're in an anabolic state, then you are building things to store them, right? And there's an overall consumption of energy, okay? So anabolic is you're building things up. Catabolic reactions are where you're doing the opposite, where you're actually breaking the complex molecules down into the smaller ones. So this is more of like a tearing down process and leads to an overall release of energy that can then be utilized by the cells. Okay, so again, before we get too far forward, really important to understand these two terms. Anabolic, we're building things up from simple pieces to making them larger. And this is an overall consumption of energy, right? So we store away energy for later. Catabolic reactions are taking the big pieces and breaking them down into smaller pieces to be utilized as energy. Okay, so building up, tearing down, anabolic, catabolic. It's important to understand digestion itself is a catabolic reaction that can be broken or accomplished by enzymes that get secreted into that alimentary or GI tract, mainly in the small intestine, right? It's by no accident that this small intestine is anywhere from 3 to 7 meters long. This is going to be where the majority of your digestion and your absorption can occur. And it has the longest amount of time traveling through that organ in order to accomplish that. Energy output is going to result in heat loss, which helps to maintain our overall homeostatic body temperature, which is mainly regulated by our hypothalamus. It's just another little key part of whenever we're creating this energy, all that energy output, that's going to result in lost heat, right? Which helps to maintain body temperature as well, right? So this is a heat generating process. All right, when we talk about metabolism, we can break this down into two major categories, anabolic, catabolic, but we can also break metabolism down into the 3 stages required for actually processing our food to make energy, okay? So you have these 3 stages, we'll define them really quickly. Stage 1 is digestion and absorption in the GI tract before we transport all of those broken down materials into our tissues cells. Okay, so this is all about we're in the GI tract, we're actually digesting, we're breaking down our food into its smaller pieces, into those macronutrients, micronutrients, what have you, and then we're going to absorb them in our GI tract. Stage 2, those nutrients can then be built into other macromolecules, right? So into larger things. This would be an anabolic reaction because we're building something. Or it can start being processed to use for energy, which is breaking it down, which is catabolic, right? So tearing down something to use it for energy is catabolic. And this happens through a process we will call glycolysis. And this happens in the surrounding cytoplasm within our cells. Okay, so all throughout our cells, your body is doing this in order to create energy throughout the cell. And then finally, stage 3 is referring to the citric acid cycle and the electron transport chain, or ETC, which is otherwise termed oxidative phosphorylation. Guys, we're going to break down exactly what these are. I know those are really heavy terms, but this is happening in your mitochondria, and these are the primary means outside of glycolysis for how your body can produce energy very efficiently. And I love this visual, right? This is going to be a visual breaking down all 3 of these stages, but what I really want to focus on here is where is it happening, and each of our major macromolecules, those macronutrients, how are they being processed differently? Whenever you consider a success criteria for digestion and nutrition, this is a key part of that metric, right? Which is, can you, for one, trace a food's pathway throughout the the digestive system? And then secondly, do you know at what parts each of these macronutrients are being broken down and how they're being utilized for metabolism? Okay, and this is a really good visual that helps show that process and where it happens. So you can see along the GI tract, you have these major macronutrients that we've covered: your carbohydrates, your lipids or fats, your proteins. And those are going to be broken down in this stage 1. Digestion and absorption is going to be broken down into their smaller foundational pieces. So proteins become the little amino acids. Carbohydrates broken down into glucose primarily, but other simple sugars as well. And then your fats can be broken down into glycerol and then fatty acids as well. Okay? Now, amino acids, glucose, glycerol, fatty acids, once those are broken down, they can be absorbed because they're small, and then they can be transported into stage 2, which is going to happen in each of your body's tissues. Now, the amino acids are going to be proteins made available for building things within the cell. Again, proteins have so many jobs that it's really hard to define a major one because they do so many things. Your glucose is going to be, can happen in 2 ways. If it's catabolic, then it will be starting the process of what we call glycolysis, which is your body's means of using glucose or blood sugar in order to create energy, right? So it's an energy creating pathway. And the end product of that will be what we call pyruvate or pyruvic acid. That can then be utilized in the next stage to create even more energy from that same little glucose. If we have enough and we're in an anabolic or building state, you can see right here this light purple arrow. This means that we can store that up, build it up as glycogen. We can break it down later as needed. And then finally, your fats will be broken down into glycerol and fatty acids within the cell. Both of those can be utilized if we're in a well-fed state. We can store those, build those back up, and we can create stored forms of triglycerides. Or we can break each of those down individually and then catabolically use them for energy as well. Glycerol will be entering the same glycolytic pathway, so it can be used for energy. Fatty acids, we'll see them later. So from this, and amino acids, I should also say, would also be seen later. We can use those in glycolysis as well. Okay, so basically we've broken down in our GI tract for stage 1, we've broken down these very large macronutrients, and now they're in their little foundational fundamental pieces. Okay, we can then use those little pieces to either build things up within the cell or break them down and use them for energy. Now, once we've gone through that glycolysis pathway, right, and we've created a good amount of energy in the cytoplasm of the cell, then remember what else we have, that main powerhouse organelle, which is your mitochondria. Each of these little broken down pieces, along with the pyruvate that we've created, can go into the mitochondria, and the mitochondria has 2 pathways that it can use, 2 ways in which it can create further ATP using the same products that we have available. Those include the citric acid cycle and our oxidative phosphorylation, which is more of like an aerobic means. It means oxygen is going to have to be required in order to facilitate this process. So we have to be breathing and not out of breath, if you want to think of it in terms of your activity physically. And so we can use these 2 means, so glycolysis, the citric acid cycle, and oxidative phosphorylation, or the electron transport chain. And all of these things can be used to create energy, usable ATP, that energy currency within your cell to keep things going. All right, so there are 2 nutritional states that play into this, right? Whether or not we're going to be anabolic or catabolic, okay? If you are in an absorptive state, this is just to say that you are in a fed state, right? You're not starving, you're not fasting, you have food in your system, right? And this is going to typically be from the time of your last meal, it being completed. It'll last about 4 hours after you start eating, okay? So nutrients are moving from your GI tract into your blood during this absorptive state. We're absorbing nutrients. And this is going to be anabolism exceeding catabolism, right? So what we're building or storing is higher than what we're needing in terms of our body's energy needs and what we're breaking down. So we have more than what we need, leading to we can store some of this away for later. Okay, so our major energy fuel in the body is glucose. So any excess glucose will then get stored away as fat or muscle glycogen, so that if I happen to get into a fasted state and food is not available, I can then use it. Okay, and it's all going to be controlled and directed by this hormone we call insulin. Okay, so low levels, high levels will control and direct insulin, and insulin will then control and direct how we utilize this energy currency we have. So we have our absorptive state where we're actively absorbing and we have food in our system. Postabsorptive is going to be referring to now I am fasted. It has been past that average of 4 hours. I don't have anything new coming in, and the GI tract is therefore empty. This is going to refer to catabolism, where that's exceeding anabolism. Okay, so I have more needs in my body than what I have new energy coming in or available. So I'm not building things now. I stop synthesizing new fats, new stored forms of glycogen, and different proteins that I need to build. And I actually instead start breaking them down so that I can continue to serve all of my body's needs. So major energy fuel here is going to be your body reserves. Glucose is going to have to be made available, like for the brain, for example. And so glucose can come from a variety of sources. It can be broken down from glycogen in the liver, broken down from glycogen in your skeletal muscles. You can convert glycerol in your fatty tissues in the liver, right? So we can break down stored fat to create glycerol to create that glucose. And then also, as an absolute last resort, this is like a very prolonged fasted state, but we can, in dire needs, break down proteins from our tissues as needed. They do so many things in the body. We don't want to break those down and utilize them for digestion if we don't have to, but we can if necessary, right? If it's survival on the line, we will do so. And then finally, this is all going to be controlled or directed by what we call glucagon, right? That sort of opposite of insulin, and the sympathetic nervous system can also play a part. And then finally, guys, this is a little bit longer of a part here, but the liver, right? One of these major players in the digestive system is one of our key organs. One of its major roles is processing the majority of our nutrients. It processes the nutrients that we bring in and regulates our plasma or blood cholesterol levels. Cholesterol is a steroid that the liver creates. It's found in many body tissues, big part of our plasma membrane, so all of those outer boundaries of the cells. The liver is a key player in actually creating the building blocks of that. And then its structural basis for bile salts, other hormones, vitamin D, all of these things the liver plays a role in. It can also make lipoproteins or fatty proteins for transporting other lipids like cholesterol within the blood, regulates entry and exit from certain cells so that it's another way in which it can provide energy to these cells. Okay, so wanted to make sure that I addressed that. That is a nice little overview of metabolism, and will conclude our conversation for concept 2, which is all things nutrition and metabolism. Hopefully you see how all of this for digestion, nutrition, metabolism, all of that plays a role and functions together. And we will continue our conversation moving forward, where we finish this unit by looking into the urinary system. We will pick up there in the next concept, and we'll see you then.